Hello and welcome to this introduction to Agents.jl, the Julia library for creating agent-based models. In this tutorial, I'll show you how to set up your basic environment so that you can get started with creating your own agent-based models using the Julia programming language. But first, let me quickly say something about why we would like to do agent-based modeling using the Julia programming language. Julia is a language that is, and I'm just picking this off of the Julia website, it is very fast. It is a language that compiles using the LLVM compiler to very efficient machine code, so you can achieve performance similar to programs that are written in the C language, which is considered to be one of the fastest language on any machine. Another benefit is that it is dynamically typed, so it is as easy to write as in a scripting language similar to Python or R. It has an integrated environment mechanism, so you can have reproducible environments. Other people can reproduce your results and they will get the exact same answers as you will get. So your models are in a way encapsulated, and others will not have a problem figuring out whether your results are correct or not. Julia is very composable. It is due to the pattern called multiple dispatch. It's a way of how Julia organizes its own functions. It's not an object-oriented programming language. It's not a fully functional programming language, but it uses kind of like the best of both worlds. So you can create object-like structures as structs, and you can create functions that are sensitive to the structs that they are using, so that you can have something like polymorphism without the, if you know what that means, without the overhead of an object-oriented programming language. It is open source, so everyone can use it using the very permissive MIT license, and it works on almost all operating systems. To get started, you can click on the download button on the website julialang.org, and this will get you to this website where you can pick your individual best fitting Julia installation. In my case, this would be a macOS x86 64-bit version, and I would prefer downloading this as a DMG file. And while this downloads, this is about, on a Mac, about 100 megabytes. And as soon as I open this, I can just basically copy over Julia to my applications folder by dragging this over here. Since I have already installed Julia, it's asking me to overwrite it, and I can basically simply overwrite it. And the next thing that we need to do is start Julia, and that's all that we're going to need to install. In this case, everything else will be installed from Julia. To start Julia, I can go into my program setting, and you'll see I have lots of other stuff here. And I will start Julia 1.7. Julia has been downloaded from the internet. Yes, I would like to open Julia. And this opens a small REPL. This is what this is called. Where you can basically run Julia commands, and it will evaluate something like 1 + 3 = 4. And the first thing that I want to do is, this is executing in the Julia environment. So this is where my application is, and we're currently, I think, in my home folder, and that's not where I want to be. Another thing is that this message here, hi, I'm using my defaults from a custom startup.jl. You should not see this. This is a file that I have created to personalize my Julia experience. You will probably not notice this here, that it just affects how many threads I have available in multi-threaded simulations. So don't worry if you don't see this. The Julia interpreter allows you to also run shell commands and to change directories. So if I press the semicolon, I get into the shell, and I can now run something like ls. And this tells me I'm in my home directory, and I would like to go into my Julia workspace. I can do list here as well, and I want to go into ABM demos, and this is the folder where I want to be. And here I'll create a demo tutorial 01. I'll go into this directory, and this is where I want to get started. To exit out of the shell, I just hit backspace, and I'm back in the Julia interpreter, and here I can now run Julia commands. The first thing that I want to do is I want to, using the package manager, I want to install a new package. For this purpose, I will first say using pkg. This allows me to use the methods of pkg, which does something. For example, I can now call activate. I will give it the dot as a string, and this allows me to create an environment in my current directory. Activate not defined. Okay, I think I have to call it this way because when there's multiple activate functions, it cannot identify which one it is, and activate is not exported by default. So the error says undefined variable error. Activate is not a defined variable, and yeah, the stack trace we can basically ignore at this point. But if I do this, I do package.activate. It says I'm activating a new project in Julia workspace ABM demos tutorial 01. If I go back into the shell and I say open dot, this is a command of macOS that will open a finder in this directory. It basically says, okay, this is the folder that we're in, and as soon as we're installing libraries, you will see something happen here. Back in Julia, so I hit backspace to go back to Julia. I want to now install a package called Pluto, Pluto.jl, which is an interactive web-based environment. It's similar to Jupyter Notebooks, but in a more advanced way as they are reactive. By the way, there's another way to install packages. So a typical way to do this would be pkg add and then say Pluto. This would install the Pluto package. But another thing that you can do is by entering the closing square brackets, I go into the package manager, and there I can also say add Pluto. So this will add Pluto to my dependencies, and Julia does all of the necessary things in the background for me, so I don't have to worry about in individual dependencies between libraries. It figures out what dependencies are there between different libraries, and it will get installed. And as soon as I'm done, you see here on the right, we now have a manifest toml and we have a project toml. The project toml is a description of the file, of the file's dependencies. So if I give you this project toml, you can set up the project similar as mine. The manifest toml is something that Julia uses to store information about local installed dependencies. So this is a file you would typically not share. You would only share the project toml with other users. If I go back into the normal mode, I can now say using Pluto, and this allows me to, the Pluto library is now available. And calling the function pluto.run will open the Pluto environment. One thing about Julia is that not all of the libraries are necessarily pre-compiled available. So sometimes it can happen that Julia needs to compile your libraries, and this can take quite some time. It depends on whether the libraries are available or not. In our case, the libraries now were all available in either on my computer or in the pkg repository. I don't know where it got it from. 23 were already precompiled, so it didn't have to precompile these. And this is one of the challenges / benefits of Julia. Every library gets compiled on your machine to be optimized to your specific machine. This means that when you're setting up a new project, it might take a little bit longer, but after it has been set up, things are going to be very fast. And now when we start pluto.run, it has now opened a browser window, and I will zoom in and go into full screen because we're not working with the Julia REPL anymore. From here on, we'll be doing everything in the Pluto interactive environment. How does it work? We can now open a sample notebook. This is not what we want to do, but we want to open a new notebook, or we can open a notebook from a file. This can be a URL, so we can open one on the internet. And you here see my recent sessions. This is stored in my browser, and these are projects in different directories that you will not have available. So this you should not see on your computer. You should only see this new session, create a new, open a sample notebook, create a new notebook, or entering a URL. But we're going to start with a new notebook, and it should only take a moment. And as soon as Pluto is set up, we can have a look in the terminal whether it's installing other things. No, it isn't. And now we're in our notebook. The first thing I would like to do is save this. So I would here say first steps.jl. And now it is saved, and everything I will now write, if I click save, will be saved into a notebook that I can recall or I can go back into at any time. So the idea of Pluto.jl is that we have individual cells, and these cells can contain code, like I can do 1 + 3, and as soon as I press Shift Enter, it will evaluate. And in this case, you see it took quite some time because it was compiling some things for the first time, and all of this is not shown to you. You only see how much time the actual calculation took. That was 21.5 microseconds. So not very fast, but it's a first operation. And one thing to keep in mind, in Julia, things are a lot faster when you write functions and you save functions, because they can be precompiled. If you do something in the main scope, it might be a little bit slower. So be aware of that. These numbers, they will improve. So we can do basic calculations similar to a Jupyter notebook. Another thing that we can do is we can put in markdown code. And for this, we just type MD and 3 quotation marks, and we go into the next line and also add 3 quotation marks, and anything that we'll write here, say this is text, this will evaluate to a evaluated markdown comment. We can now click on the icon to remove the code that generates this output. And of course, we can actually format our text. So this, we can say, this is a introductory Pluto file. Here we will have a look at Pluto.jl and its benefits. And now we get basically descriptory text, and we can describe what we're doing using Markdown in individual chunks, and can hide the documentation text in this case. Clicking on the plus button will add another cell. Also Control Enter, at least on a Macintosh, will add cells. Deleting an empty cell will delete the cell. Clicking on these buttons on the right, you can also delete cells even if they're not empty, and you can disable cells. So cells that are expensive in code that you don't want to run at a certain time, you can disable for a moment. So what is one of the key features of Pluto? So if I, for example, create a variable a and give this a number, Julia automatically recognizes that a is a number, and it just evaluates a to the value 3. And if I go into a different cell, I can now say a times 2, and this evaluates to 6. Obviously, 3 times 2 is 6. But the nice thing about Pluto.jl is it is a reactive environment. So whenever I change this to 4 and press Shift Enter, all cells that depend on this variable will get updated. And to understand how this works, we can also do something like b equals a times 2. And b is now evaluated to 8. And when I put 5 in here, it's evaluated to 10. And if I put 100 in here, it's evaluated to 200. This comes with a compromise. So one thing that I cannot do is I cannot access the variable b here. If I do this, we will get an error that says cyclic, I don't know how that's pronounced, references among a and b, because obviously if b is defined by a and a is defined by b, this does not make sense if they would continuously update each other. That doesn't mean that variables cannot depend on one another, but if we want to have more complex interactions between variables in an iteration, we could do something like this. So we could have a equals, and we're going to call this not a but c equals 4, and d equals c times 2, and then we could also say c equals 4 plus d, and then end. And if I evaluate this, then c in the end is evaluated to 12. The output of any of these cells is always the result of the last line of this code. So you're not seeing the d value, you're seeing the c value at the end. So it is possible that c depends on d, where d is calculated by c, but it has to be wrapped in a begin and end block to make sense in this regard. So what are the different types of variables that we have? We can have a variable that is a number. Let's wrap all this in a block so we can have multiple lines of code here. We can have a number variable like this. We can have a string variable that is created like this. We can have very easy interpolated strings by doing this $num, which will integrate expressions, Julia expressions in the text. We can have decimal numbers by putting in a decimal place. And we can have things such as tuples. A tuple variable is basically just created by adding numbers in brackets with a comma. We can have vectors. A vector variable is basically created by using square brackets. We can also have matrices by putting semicolons to separate the rows. And we can also create errors. Oh, this should be a matrix variable and an array variable. These are created by brackets and using commas in between. 1, 2, 3. So this would now set up these variables, and you would see in the end we get the last variable output here, and this is an int64, which basically means these are integer variables, and we have 3 of them. The indexing starts with a 1, so it's a math-oriented language, not a programming-oriented language like C, which starts arrays indexing with 0. And each of these integers is assigned an 64-bit value because I'm using a 64-bit machine. I can also access the other ones. So if I do text num, it evaluates to this is number 4. If I do text decimal, that doesn't make a lot of sense as a variable name. This gives me a 4.5. If I do a tuple variable, the output looks like this. And if I click on this, it shows me basically that this is a tuple and these are individual integers in this case. If I have a look at the vector variable, I will see that this is a 1x3 matrix and each of the entries is an int64. And if I do a matrix, I get a 2x3 matrix where each of the entries is an int64. Of course, there are more things that you can do, but I think this is quite sufficient to get a basic understanding of how variables are treated in Julia. Another cool feature is how you can create arrays using, for example, array comprehension. If you want to set up square numbers, you can basically say something where I want to have all the I for all, let's say I want all the I square for I in 1 to 10. So what this basically does, it evaluates this for loop and puts this into this equation, and this is then added into the array. And if I run this, I get now an array with the square numbers from 1 to 10, so 1, 4, 9, 16, 25, 36, and so on. Another cool thing about Pluto is that we can now have variables that we want to address on the interface. And for this, we would be using a variable. So let's put in a new section here. We'll do this by putting in Markdown and using a new section heading, Pluto interactive features. Because one thing, it's kind of nice that we could basically just go in here and say 14. And now we would get a bigger array, but that's not the nicest form of interaction. We would probably want to do something more easily handleable, and we could say we create a variable max number, and that would be, for example, in this case 10. And wait, let's do it a little bit differently. Begin, no, that doesn't make sense. Begin, end. And here we would then override, or we would create a variable called squares, and it basically does the same thing. It goes I to the power of 2 for I in 1 to max number. So this would be a way of making this depending on a variable. So if I do 19, we would get 19 square numbers, but we don't want to manually put in something here. So we could do something like the following. We create a markdown block, and in this markdown block we ask the user, how many square numbers do you want? And we will put in a Julia expression here, and the Julia expression uses an @ bind, which means bind a variable to something, and the variable that we want to bind is the max number variable, and we want to bind that to a slider, which we still don't have available. We would have to import this from, let's say, 1 to 20. That would be the range of variables. We'll now get an error because max number is defined twice. We'll remove this here, but also the bind macro here is not defined. It says two things. The slider is not defined, and the macro expansion. Oh, the macro expansion is the cause of the error. So the bind macro is available, but the slider is not available. And this is due to the fact that it's in a different library. And the library is called, using Pluto UI. And what you see is it immediately tells you, if there's this download sign, that this is a valid library name. If I put in a wrong character in here, it will immediately tell you, no, this is not, the package Pluto UI could not be found in the registry. Did you make a typo? Yes, we did. And if we now put in Pluto UI and execute this cell, it will basically do all the work for us. It will download Pluto UI in the background and install it and make it available. We don't have to call the package manager in Pluto. Actually, we shouldn't call the package manager, because then the automatic installation of packages does no longer work. So what this now does is it creates a slider here, and the slider then, if I move this around, it will change the variable name max number. I can hide this. So by moving this around, I can determine how many square numbers I want. Maybe it makes sense to have an output here that tells us how many we do want to see. So I can do something like we're creating, and then we're just using the variable, called max number squares. And here in all these markdown blocks, I would basically hide the content, and the library loading, I don't know, maybe you can hide this as well. It might be helpful to have this still visible because it doesn't generate an output. And what we now have is we have basic interactivity. And you might ask yourself, okay, how do I know all these things? If I go in the slider here and I click on the live documentation, I see how the slider function works. So in this case, it basically says I can bind a variable to a slider. I can bind the variable to this type of array generation where you have a stepping function. You can also set a default value. Importantly, if you want to set a default value, you might overlook this because every function in Julia has unnamed parameters, and this Julia determines what these are used for by the order. So the first parameter of the slider is always an array. It can be a numerical array. It can also be an array of strings in this case. And after that, where you don't need a variable name, after that you have named parameters, and these are separated using a semicolon. So this semicolon here is necessary because it basically means that all the parameters afterwards, they need a name. So you cannot just say 1 to 10, 8 true, but you need to say 1 to 10, default is 8 and show value is true. The benefit of this is that you can pick and choose which of these parameters you actually want to set, but you have to name them because otherwise Julia doesn't know which ones they are. So we could say default equals 10. And this means when I reload all of this, let's run this, the default here will be 10. What was the other thing that we wanted to see? Show value true. Yeah, let's do that as well. Show value true. And then we get instant feedback here as well. So we might have saved on this other output here as well. So just to be sure, before the semicolon, we have the unnamed parameters, and after the semicolon, we have the named parameters. You will see functions where we're not using the unnamed parameters, so then you would have a semicolon directly at the beginning of the function parameters. So if you ever see that, it basically means you just have named parameters in this function. So one thing we can now do is we can have reactive code, and something else, even if it's above, could react to this here. So we could add something here that basically says square numbers plus squares. The dimensions, oh yeah, that's a thing though. It has to be the same dimensions. So in this case, this only works if this is 14 numbers long, because otherwise you cannot make a sum. The thing is, this plus basically means sum the individual entries. So if you sum two arrays, it's kind of like vector summation. It's adding the individual numbers. So in this case, maybe this is not the safest function. Let's close the documentation. Let's delete this cell. This is nothing we want to do. The other things that we can do as interactive inputs, you can find if you highlight Pluto UI and go into the live documentation. Here you see all the other different fields that you can have. So you can have buttons, you can have checkboxes, you can have a clock, you can have a color picker, you can have a date field, a date picker, a password field. So there are many different ways how you could bind variables to different types of input. And a typical thing that you would probably need is something like a checkbox. We can maybe create a checkbox quickly. Markdown. Do you want to show the last number? We'll do it like this. And in the next line, we'll have our $, and we will bind show number to a checkbox. And the checkbox, because I have the documentation open, it will immediately tell me how this works. and it can have a default, so whether it should be true or not. Let's say the default is true, and we have to close the markdown block. And now I can, so by clicking this variable, we can change a function, a variable called show number, and we could do something here. If show number, do something, and what you should do in this case is maybe print line squares. So from this array that we have, we might want to use the last object. I think there is a last, I'm not sure. No, array has no field last. Maybe there's a function called last, I'm not sure. 196. So what this here is if you see something in green with a question mark, you can click on it and basically tells you this text was written to the terminal screen while running the cell. It is not the return value of the cell. So in this case, this block here does not return anything, but it prints something to the console. And if you were to run this in the Julia terminal, I mean, we can open the Julia terminal. These are the outputs that Julia generates. In this case, this terminal output is caught and not shown on the actual terminal, but it's shown in Pluto. But this is typically not what you would like to do in this case. So printing is something that you could do for debugging, but I would say that is not something that you would typically do in this case. You would rather have a markdown block where you evaluate the variable. So we could basically just do something like return squares. Return is a function, so you can only use, I can only use return in the function, so I cannot even return at this. But we could basically just say squares, last of squares. So because this is the last expression that's evaluated, this is now the output here. So this basically gives you the highest square number in our array. And what you can now see is how long does it take to calculate 20 square numbers? It takes 3.5 microseconds. And how about we allow more than 20? How about we allow 2000? This still takes about 3.3 microseconds. If I go to 634, we are up to 4 microseconds. If I go to 2000, we're up to 7.2 microseconds, so it's not a big problem. Let's increase this by the factor of 10, and now we're up to 76.3 microseconds. So in this case, we can see we're almost at a point where most of the duration of this code is actually created by the code and not by the overhead of starting a begin block and so on, because this is about 10 times the amount that it took before that. Let's add another 0 here, and we should be... Wait, what happened? Did I add another? Oh yeah, it's still 3.4 microseconds because I didn't move the slider. Okay, and now we're up to 665. We can always rerun this, and we see that it fluctuates somewhere between 100 microseconds and I think there was even 1.4 milliseconds. And why does it fluctuate? One of the reasons it fluctuates is because there is some pre-compilation going on, and it depends on whether it can reuse the code, or here there was also 4 milliseconds. This will be a lot more effective if we put this in a function. So if we create a function, generate squares, and this will get a, let's say, call m number, and here we will only say m number. If show number, yeah, this we shouldn't have here. We will just return last of squares. So the way you create a function, in this case it's called a generic function because it doesn't know what type of variable m number is. We could tell it that this should be an integer variable. because it doesn't make sense if this is a string. Let's call generate. By the way, if you type and if you press the tab button, you get autocompletion. I can call generate squares, for example, for the number 10, and this would generate all of the squares and just return the last one. So it's just producing a lot of overhead without actually being sensible to just return the last of them. But if I don't make this if I make this a generic function, I could even put in a string here, and this will fail because this here is not defined. A array from 1 to test is not defined. So in this case, it makes sense to limit this to integer variables for this function. I mean, you could in theory also have rational numbers or doubles in here, which is the data type for decimal numbers. But I think for us, because this is used as the index for an array, it only makes sense for integers. If I'm not putting, you might wonder why I'm not putting in int64. The reason for that is, let me quickly evaluate this and evaluate this. Oh wait, this doesn't make sense. This is where the error came from. The reason I'm using int instead of int64 is now this forces Julia to use a 64-bit integer, and this code now will never run on a 32-bit machine. If I say int without adding I could also say int32, that's possible. Oh no, that's not available, interesting. So, because the 10 here is created as an int64. That's interesting, because if I don't define a variable to a certain type, it will basically try to select the variable that is closest to the system. So in this case, the 10 would be represented as an int64. I could define it as, and let's quickly do this, begin, end. By the way, if you're in a situation like this, by pressing Alt and up, you can move individual lines in certain directions. So I could create a variable a, which is of type int32, and say this is 10. I don't know if I now get a clash with the variable a on top. Syntax begin, and got a. Wait, that's how it's multiple definitions for a. Okay, let's not call this a, let's call this demo type, where we demo that something has a type. So type declaration on global variables. Okay, yeah, that's the thing. We cannot declare a variable on the global scope as an integer. We can. We just cannot use our own types. So this is now an int32, and now this function evaluates correctly because it allows the int32. If I say int, it will no method matching. Interesting. The closer. That's interesting. So the int variable is always, or the int type is always evaluated to the type that is machine specific. So in this case, it would be evaluated to int64, so it wouldn't find a matching function. So let me copy all of this and put this here and put in a int64. So what happened now is I can give the same function name. I can create the same function twice if I have a specific signature for the parameters that are being used. In this case, I have only one int32 variable. In this case, I only have one int64. And depending on what is being used here, a different function is called. And we can easily demo this by doing a print line in here. I'm a 32-bit function, which is not actually very accurate to say, and I'm a 64-bit function. So in this case, if I put in a 32-bit value, it's calling the 32-bit function, and if I'm putting a 64-bit function, it's calling the 64-bit function. In this case, this doesn't really matter, so it doesn't really make sense to have a difference here, because you would normally just say, let's have int and remove this, and define this as an int as well. And in this case, we don't even need the output. So this is how you normally try to achieve this. You just tell it that it's an integer, and this now will run on 32-bit machines, on 64-bit machines, and it will use the largest available integer size. This can become important if you want to store a lot of these. So if, for example, you can also create an int 8, which is an 8-bit integer. It can only store numbers from 0 to 20, 255. This uses 4 times less memory. So if memory is your problem, you can use smaller data types if you think they are helpful. What is the benefit of what we've just seen? So one of the benefits what we've just seen is this is the multiple dispatch pattern. We call a function, and depending on the types, on the arguments that we're submitting to the function, a different function can be chosen. And the benefit of this is that you can extend everybody else's code. If someone writes generate squares for int, and you come up with a very clever solution that does this with booleans or with strings, you can just write the function, and everywhere where generate squares was used, now it can also process the function when it gets a string. So this is a way of making the function independent of the data types. And this is true for all things, such as, for example, 1 plus 3. The plus that is being used here is actually a function. And wait, this I didn't want to do. So the plus 1 and 2, this is the function that is being called. And in this case, this is the plus function that adds int and int. So if I do something like this, it will tell me, okay, I cannot find a matching function that will add an int 64 to a string. I find some candidates like the any to any, that basically means do something where we have an undefined variable. And this will then, the interesting thing is in this one, it will basically just separate into the different solutions. So here's a very long list of different types of how this could be interpreted. You don't really need to understand what the error message here says. It basically, what is important is you did no method matching. So there's no sensible plus defined for something like 1 plus test. This doesn't make sense. You could write a function. You could write a function plus that gets a number a, which is an int, and a value b, which is a string. And you could basically return a, ignore whatever the string says. I need to create another cell here because that is another thing that I haven't shown you. Sometimes you will come across this problem: multiple expressions in one cell. How would you like to fix this? Split the cell into 2 cells or wrap all code in begin and block? In this case, we want to split it. There can only be one result of any cell, and a function returns the function. So generating this function creates a function, and this results. This has an output as the result of the function. And what I've now done is I have now created a plus that is able to combine a number with a string. It doesn't really make a lot of sense, but now I can do this wherever I want. I can always say 8 plus test, and it will return 8. So I'm able to override any function that is available in Julia with a different set of parameters, and this allows for extreme flexibility. For example, if there's a plus function defined for integers, you can then very easily write a plus for matrix addition. I mean, these things exist. Someone else has done this. But if you come up with a different data type that has addition, and it's based on basic addition, you can very easily create your own algebra if you ever would need one. Let's remove all that. Okay, we've seen some more of the Julia language, and we've seen some more of interactively setting something. And we were actually trying to do this to find out how much faster this is if we run it in a function. And in this case, we already see generate squares returns the 100. And in this case, the demo type is this number 10, but we could also always just put in the max number. And this returns, so this function is now called with the max number that I set up here. And if we now rerun this, we should see that it's a little bit faster. Not a lot. Maybe the function, maybe the begin block does something as well. But I think we were around 400 microseconds, and now we're more down to 150. And if you want to be sure, one thing that you can do is do the add time command. If you really want to know how much time a function typically consumes, you can run the add time command, and this will give you a timing on that one. I think there's also an add benchmark, if I'm not mistaken. No, I think that, yeah, that was a library that you can run, and it would basically call this function 1,000 times and then tell you statistics on this call. So here you can already see the timing, the evaluation of the block was 1.5 milliseconds, but the actual function only took 4 microseconds. So what sometimes takes longer in this case is that in this case, it will always take longer. We can see this here because there is something printed to the terminal. And printing something is always expensive. That's why you typically don't want to print to the terminal. So the actual function costs about 150, 180, 130. Yeah, that's about the performance we get. There was one that was fast, one that was slow. So that's about the performance that you would get if you put this in a function and allow the compiler to optimize the function. And what takes long here is outputting this to the console. So we're not doing that anymore. And if I rerun this now, yeah, we get mostly higher performance than if we ran this normally. So that is something to be aware of. If you have code that is very expensive, it makes sense to wrap it in a function and basically just call the function. So even if you want the maximum number to be hard-coded, if it's just a fixed constant, writing it in a function saves time. And this is where our tutorial for today will end. I'll see you in the next tutorial when we'll get started on setting up an agent-based model. By the way, if you feel that you haven't been introduced to Julia well enough, there is excellent documentation on the Julia website. So if you go to the Julia website, there is also the Julia documentation, which I've opened up here. And there, if you go into the manual section, there is a getting started guide, and then there's all types of aspects of the programming language laid out for you one after another, and it's written in a tutorial style manner, so it's very easy to follow. And by going through the documentation, you will definitely learn a lot about Julia, its benefits, and how it's used properly. With that being said, I would say we see each other in the next video.